Hello, and welcome to day one of AI Zero to Hero. First of all, start with what is artificial intelligence. So, ChatGPT can write code, AI can detect cancer, cars can drive themselves. But here's the truth: most people of use most people use AI. Very few understand AI. In this 30-day series, I will take you from zero to hero in artificial intelligence step by step in simple language. So, what is artificial intelligence first? Artificial intelligence means making machines capable of thinking, learning, and making decisions like humans. AI is not magic, a robot brain, sci fi fantasy. AI is math, data, algorithms, computing power. If humans learns from experience, AI learns from data. And real life examples could be like you already using AI every day. Google Maps predicts traffic. Netflix recommends movies. Amazon suggests products. Voice assistants understand your voice. All of this is AI. AI is invisible but everywhere. AI versus machine learning versus deep learning. Most beginners are get confused here. Let's make it simple. Artificial intelligence, the big umbrella, machines that act smart. Machine learning, subset of AI. Machines learn patterns from data. Example, predict house prices using past data. Deep learning, subset of ML, inspired by human brain neurons. Example, face recognition, speech recognition. A simple formula. AI is subset of ML and subset of DL. Types of AI, narrow AI, chatbots, recommendation systems, face recognition. This is what we use today. General AI, future. Think like humans, reason and adapt. This does not exist yet. Super AI, sci-fi. Smarter than humans. Movies love this. Reality doesn't have it. What AI can do? AI can see, hear, read, and write, predict future outcomes, detect fraud, diagnose diseases. Key idea: AI is equal to pattern recognition at scale. Myths about AI. Let's break the biggest myths. AI will take all jobs. AI will change the jobs. You must be genius. No, you must be consistent. Only PhDs can learn AI. AI can start today. Anyone can start today. How this 30-day series will work. Here's what we will do step by step. Python easy, machine learning, deep learning, generative real product projects, deployment. By day 30, you will build AI projects, understand how AI works, be confident in AI interviews. Day one assignment would be for you. Write like your task today is write down 5 AI applications you use daily. Comment below. I am starting AI day one. Subscribe so you don't miss day two. Learning starts with commitment. The day two would be AI roadmap, career paths, and salaries. Here is day two. AI roadmap plus career paths. You watched day one and now you are excited about AI. But here's the problem. You open YouTube and see learn Python, learn machine learning, learn deep learning, learn ChatGPT, learn math, learn everything. This is where most beginners quit. Today day 2 I will give you a clear AI roadmap and show you exact AI career path so you know what to learn, what in what order and why. Why you need a roadmap? AI is not hard, AI is confusing without direction. Without roadmap, you jump between topics, you forget what you learned, you feel stuck. With a roadmap, you progress step by step, you stay motivated, you build real skills. Key line would be roadmap removes fear. The complete AI roadmap. Here is the exact roadmap we will follow in this series. Step 1 is programming Python. Learn basics only, no advanced coding needed. Step 2 math for AI. Very basic math. Focus on understanding, not formulas. Machine learning predict outcomes from data. Deep learning image, voice, text understanding. Generative AI, ChatGPT style models and prompt engineering. Projects plus deployment. Real world AI apps, portfolio building. Simple to learn, build, and show. In detail, Python. Python is a language of AI. You do not need web development competitive programming. You only need variables, loops, functions, lists, and dictionaries, NumPy and pandas. If you can read and write simple Python, you are ready. Step 2 in detail math for AI. Let me be honest. You don't need PhD level math. You need mean and average, probabilities basics, graph intuition. Math is used to understand models, not scare you. Confidence booster. AI math is learnable by anyone. Machine learning. Machine learning means let data teach the machines. Examples predict house prices, detect spam emails, recommend movies. You will work with datasets, models, accuracy scores. This is where AI starts to feel real. Deep learning. Deep learning is inspired by the human brain, used in face recognition, medical imaging, voice assistants. You will learn neural networks, CNN, RNNs, text and speech. Key idea deep learning equal to advanced pattern learning. Generative AI, this is the hottest field right now. Generative AI can write content, generate images, write code, talk like humans. Skills you will learn. Prompt engineering using AI APIs, building chatbots. Projects and deployment. This is where most courses fail and where you will win. Companies don't ask what course did you watch. They ask what have you built. You will build ML prediction apps, AI chatbots, image recognition systems, and deploy them so anyone can use them. AI career paths. Now let's talk careers. Machine learning engineer build ML models, strong in Python and ML. Data scientist, data analysis ML, business insights. AI engineer ML plus DL plus deployment, most in demand role. Gen AI developer, chatbots, AI tools, LLM based apps. Truth one roadmap, many careers. Day 2 assignment. Choose one career ML engineer, AI engineer, Gen AI developer. Comment below as my goal is and your goal. Subscribe for day 3. Clarity creates momentum. Welcome to day 3 of AI 0 to Hero. Python setup for AI. First program. Most people fail at AI on day 1. Not because AI is hard, but because their setup is confusing. Today, day 3, I will help you install Python, set up tools for AI, run your first Python program. No prior coding language. Let's do this together. Why Python for AI? Quick question, why Python? Because Python is easy to read, powerful, used by Google, OpenAI and Netflix. All major AI libraries are built for Python. If you know Python, you can do AI. Tools, you will only need three tools: Python, VS Code, Jupyter Notebook. That's it, no heavy software. Install Python, go to python.org and download Python 3.10 for or above. Very important, check add Python to path. This saves hours of frustration. Step 2 is install VS Code. VS Code is our code editor. Why VS Code? Lightweight, beginner friendly, user used by professionals. Download VS Code, open extensions tab, install Python extension. You don't need to customize anything today. Jupyter Notebook. Jupyter Notebook is amazing for AI and data science. It lets you run code cell by cell, see output instantly, experiment freely. Installation command is pip install notebook, and you can run using the command Jupyter Notebook. Your first Python program. Now comes the most important moment, your first Python program. Create a file named day3.py. Inside it write print hello AI world exclamation. Run it using Python day3.py. Congratulations, you just started your AI journey. Say this clearly. How Python thinks. Python reads code top to bottom. Every AI model you will build later is just inputs, logic, output. AI is not magic. It's structured thinking. Common beginner errors. If your code doesn't work good, that means you are learning. Common mistakes. Python not added to path. Typo errors. Wrong file location. Golden rule is there where errors are teachers, not enemies. Day 3 install Python and VS Code. Run print I have started AI. Comment below. Day 3 done. Python installed. Consistency beats talent. Welcome to day 4. Python basics for AI. Yesterday you installed Python and ran your first program. That already puts you ahead of 90% beginners. Today, day 4, you will learn how Python stores data, how it makes decisions, how it repeats tasks. These three ideas power every AI model you will ever build. How AI uses Python. Before we code, understand this. AI programs are just data, logic, and repetition. Today's topics map exactly to this. Map variables to data, conditions to decisions, loops to repetition. Variables. A variable is a container that stores data. Example, age equal to 21, name, AI learner, score 95.5. Python automatically understands the data type. You can print them, print under the parenthesis age, name, and score. So using this statement, you can print age, name, and score using print and round brackets. AI models work by storing and updating values. Simple operations. You can perform math easily. Behind the scenes, AI does lots of math like this at scale. For example, in Python program, A is equal to 10, B is equal to 3. Then inside the print block, you can write A plus B, A star B, A slash B. In addition, multiplication and division inside print statement using two round brackets, and inside it you can write the expression. Behind the scenes, AI does lots of math like this at scale. Conditional statements. Conditions help Python make decisions. It is like mark equal to 75, then if marks is greater than equal to 50, print pass, else print fail. This is how AI decides spam or not, fraud or safe, disease or healthy. Comparison operators: greater than, less than, equal to, greater than, equal to. Important indentation matters in Python. Indentation matters in Python. Part 3: loops. Loops repeat tasks automatically. This is the heart of AI training. For loop in Python would be like for I is a variable in range 5, means it will go from 1 to 5, and using print statement you can print the I. It will grow from 0 to 4, sorry, because the starting point is 0 and range is 5, so it will go from 0 to 4. Imagine running this loop over 1 million data points. That's AI. Count 0. While loop would be like count 0, while count less than 3. Print inside round brackets, learning AI. And you can increase the counter over here like round plus equal to 1. Key idea: loops, learning from repetition. Mini AI style example. Let's combine everything. We have given us course list like 45, 67, 89, and multiple numbers. So using for loop we can traverse this like for marks in scores, and inside it we can check the if else loop, like if marks is greater than equal to 50 then print pass, else failed. This is exactly how ML models evaluate data just at a larger scale. Common beginner mistakes. If your code fails, don't panic. Common mistakes are forgetting indentation, using instead equal to instead of double equal to, misspelling variable names. Golden rule is like read errors slowly, they are hints. Day for assignment. Your task today: write a program that stores a number, prints even or odd. Let's start with day 5. Python data structures for AI. List, tuples, and dictionaries. Yesterday you learned how Python thinks. Variables store data, conditions make decisions, loops repeat tasks. Today, day 5, you will learn how Python handles real AI data. Because AI doesn't work with single numbers, it works with collections of data. Why data structures matter in AI? Imagine training AI with one student, that useless. AI learns from thousands of students, millions of records. The data structures help us store, organize, and process this data efficiently. Key line is AI equal to patterns in large data. Part 1 list. The list stores multiple values in one variable. For example, scores is a list which stores multiple numbers like 45, 67, 89. You can access the elements using print scores 0, print scores 2. Index starts from 0, not 1. Loop through list. Using for loop, you can loop through the list like for marks in scores, print marks. This is how AI reads data row by row. You can also modify the list like scores.append 90. It will append the 90 to the scores list, and scores.remove 32. It will remove 32 from the list. Training data is usually stored in lists. Tuples. Tuples are like lists but unchangeable. Image size equal to 224 to 24. Once defined, you cannot modify it. This is tuple 1 image size. Why tuples in AI? Image dimensions, fixed configuration values, model settings. Simple rule: if data should not change, use tuple. Dictionaries. Dictionaries store data as key-value pairs. For example, student equal to in curly braces. You can write name, type of data and the original data, like name Rahul, age 21, marks 85. So this becomes tuple. Dictionary, key-value pair, just like JSON data. Using student equal to curly braces, name Rahul, age 21, marks 85. Access values using sprint student square bracket name, student square bracket marks. This is how I understand features. Loop through dictionary for key value in student.items, print key colon value. Each key equal to feature, each value equal to data point. Real AI style example. Let's combine everything. We can combine all the topics which we learned previously. This is how AI processes structured data before learning. Common beginner mistakes. Avoid these mistakes. Accessing list index out of range. Using wrong dictionary key. Confusing list with tuple. Print data to understand it. Day 5 assignment. Your task today. Create a list of 5 numbers. Print only numbers greater than 50. Create a dictionary. Comment below. Done 5. Comment below. Day 5 done. Data structures mastered. Day 6 is functions and NumPy. Core of AI competition. If your code looks long, repetitive and messy, AI projects will break. Today, day 6, you'll learn how to write clean usable code using functions. Why NumPy is the backbone of AI math. This is where Python starts to feel like real AI programming. Why functions matter in AI. AI models repeat the same logic again and again. Instead of writing the same code 100 times, you use functions. Real world analogy. A function is like a machine, given input, get output. Functions in Python. Basic function is def, greet, round brackets, colon, print the message like welcome to AI 0 to hero. You can call the create function using great and the round brackets. Function with parameters. Def greet user and in the round brackets name colon inside it you can write print welcome name. So the name would be printed which is given through the parameter of greet user function. You can run it using greet user in the round brackets double in the under the double quotes you can write any name. It would be printed as welcome and the name. Function with return value. Def at AB return A plus B. So this will return if you write result equal to add 10 and 5 and print result, it will print 15. Key idea AI models equal to functions with inputs and outputs. Let's write a mini AI style function. Def predict results result function colon inside it we can write if marks greater than equal to 50 return pass else return fail. Print predict result 72. 72 is greater than 50 so it will print pass. This is how ML models return predictions. Part 2 is intro to NumPy. Python lists are good but NumPy arrays are fast. AI uses NumPy because faster than lists, handles large data, supports matrix operations. Install NumPy using pip install NumPy on the in a terminal. Pip install NumPy. Create NumPy array using import NumPy as np. Data equal to np dot np is the alias. So np dot array. Inside it you can give the array and print data. It will print the data present in the array. NumPy operations. NumPy can perform math on entire arrays like data equal to np dot array 10 20 30. So print data plus 5 will give 15 25 35. Print data into 2 will give 20 40 60. Key insight: AI applies math to whole data sets at once. NumPy matrices. AI works heavily with matrices. Matrix equal to np dot array. Inside it you can give the matrix 1 2 3 and 4. Print matrix, it will print the matrix. Images, text embeddings, neural networks all use matrices. Common beginner mistakes. Watch out for these. Forgetting return in functions. Mixing Python list with NumPy array. Not importing NumPy as NP. If numbers are involved, NumPy is your friend. Day 6 assignment. Write a function, take a number, return positive or negative. Create a NumPy array. Multiply each value by 3. If you completed this, comment below as day 6 done functions and NumPy clear. You now understand how AI reuses logic performs fast math. Tomorrow day 7 pandas for data handling. Real AI datasets. This is where we start working with real world data. See you in data 7. Day 7. Welcome to day 7 of AI 0 to Hero. Pandas for AI handling real world data. AI is not about fancy algorithms, AI is about data. In fact, real AI engineers spend 70% of their time handling data. Today, day 7, you will learn Pandas, the most important Python library for working with real AI datasets. What is Pandas? Pandas is the Python library used to read data, clean data, analyze data. Almost every machine learning project starts with Pandas. Key line: no Pandas, no AI projects. Install and import Pandas. Install Pandas using pip install Pandas. We can import it using import Pandas at pd. pd is alias for Pandas. Iconic short name. By convention, Pandas is imported as pd. Data frame, heart of Pandas. A data frame is like an Excel sheet inside Python. You can create a data frame using data equal to curly braces. Inside it, you can give JSON style data like names, marks, past key value pair, and using df equal to pd dot data frame data and print df. It will print the data frame for you. Rows, data points, columns, features. Each column becomes an input to an ML model. Reading real data, CSV file. Most AI datasets come as a CSV file. So you want to read CSV, then you can use df equal to pd dot read CSV, and inside the round parenthesis give the data.csv or CSV file. View first rows, print df.head. It will print the header row. Always preview data before doing anything else. Basic data exploration. Before training AI, we understand the data. So shape of data using df.shape. Column names df.columns. Data info df.info. Statistics df.describe. Key idea is garbage data. It applies to garbage AI. Data cleaning basics. Real data is messy. Check missing values. df is null.sum. Fill missing values. df fill na 0 and in place true. Drop rows with missing data. df.drop na under the round parenthesis in place equal to true. AI truth. Clean data matters more than complex models. Filtering and selection. AI often works with filtered data. Select column. df square bracket marks. Filter rows. df square bracket df square bracket marks is greater than 50. So it will print data with greater than 50 marks. Multiple conditions. df marks greater than 50 and df past equal to true. This is how AI separates useful data. This is how AI separates useful data. Mini AI style example. Let's simulate an AI pre-processing step. Past students equal to df marks greater than equal to 50. Average marks would be past students marks dot mean. So print average marks equal to average marks. So using df marks greater than equal to 50, it will take the marks which is greater than 50, and using that marks we can create the average using mean method. This kind of processing happens before every ML model. Common beginner mistakes: not checking missing values, training models without exploring data, confusing rows and columns. Always understand your data first. Day 7 assignment. Your task today is create a CSV file with name, age and marks. Load it using pandas. Print student with greater than marks greater than 60 and average marks. Comment below if you have day 7 done pandas unlocked. Tomorrow day 8 math of AI. Math for AI. No fear, only intuition. This is where we remove the fear of math forever. Day 8 AI 0 to Hero. Math for AI. The moment people hear the word math, they quit AI. Let, let me tell you the truth. AI is not about solving equations on paper. AI is about understanding patterns. Today, day 8, I will show you what math is actually used in AI and why it's simpler than you think. How to understand it visually, not academically. Relax, you can do this. How much math do you really need? Here's the honest answer. For beginner intermediate AI, you need basic algebra, statistics, intuition, graphs understanding. You do not need advanced calculus, complex proofs, PhD level math. AI libraries handle the heavy math for you. Key line is understand the idea, not the equation. Part 1: average mean. Let's start with the most important concept, average. Example marks are 60, 70, 80, 90. Then average is equal to add everything divided by count. So it will become 75. AI uses averages to understand typical behavior. AI connection, average user behavior, average prediction error, average model performance. Part 2: variation. Why data is never same. In real life, data is never perfect. Some students score 50, some 60, some 95. AI needs to know how spread out is the data. You don't need formulas, just this idea. More spread equal to more uncertainty. Part 3: probability. Guessing smartly. Probability means chance, coin toss, head or tail. AI uses probability to say the email is 90% spam, this image is 80% a cat. AI never says 100%, it says most likely. Graphs. Graphs turn numbers into pictures, and AI loves pictures. AI's favorite language, graphs. X-axis equal to, for example, x-axis equal to student hours, y-axis marks, then more study, more marks, trend. AI looks for upward trend, downward trend, and no pattern. Golden rule is if you can see a pattern, AI can learn it. Distance, similarity thinking. AI often asks which data points are similar. Similarity is equal to closeness. If two points are close, similar if far apart and different. AI use cases, recommendation systems, face recognition, fraud detection. How AI this how all this comes together. Let's connect everything. AI does this, looks at data, finds averages, measures spread, calculates probabilities, detects patterns using graphs. That's it, no magic. AI is math with meaning. Common math myths. Let's destroy the biggest myths. One is I was bad at math in school. School math is not equal to AI math. I need to memorize formulas. You need to understand ideas. Math will stop me from learning AI. Fear will, math won't. Day 8 assignment. Your task today. Calculate average of 10, 20, 30, 40, 50. Think of three AI examples where probability is used. Spam detection example. Comment below days 8 done. Math fear gone. If you have learned this. Next video is on what is machine learning. Concepts plus real examples. So what is machine learning? Imagine teaching a computer without writing rules. Instead you show it examples and it learns on its own. That is machine learning. Today, day 9, you will understand what machine learning really is, how machines learn from data, the main types of machine learning, real life examples you already use. No code today, only clarity. What is machine learning? Machine learning is a subset of AI. Instead of telling the computer if this happens, do that, we say, here is data, learn patterns from it. Simple definition, machine learning equal to learning from data to make predictions or decisions. Key comparisons, traditional programming and machine learning. Traditional programming rules plus data gives output. Machine learning data plus output gives rules. This is the biggest shift in modern computing. A simple real life example. Let's say you want to predict house prices. Instead of rules, you give machine learning size, location, past prices. The machine finds patterns like bigger house, higher price. Next time it predicts price for a new house. ML learns patterns, not facts. How machine learning works. Every machine learning system follows these steps. Collect data, clean the data, train the model, test the model, make predictions. This loop repeats until the model improves. Learning for exams, practice, test, improve. Simple analogy. Types of machine learning. Supervised learning, most common. You give the machine questions and answers. Examples, house price prediction, spam versus not spam, pass or fail. Two subtypes, regression and classification. Regression is number output, classification category output. Unsupervised learning. You give with you give data without answers. The machine finds hidden structure. Example, customer grouping, market segmentation, pattern discovery. Key idea is machine discovers patterns you didn't label. Reinforcement learning. Learning by trial and error. Examples, game playing, AI, robotics, self-driving cars. Key idea, reward action, reward good actions, punish bad ones. Real world ML examples you daily use. You already use ML every day. Netflix recommendations, YouTube suggestions, email spam filters, credit card fraud alerts. Machine learning silently works in the background. If data is involved, ML is involved. What is ML is good at? What ML is good at? ML is powerful but not magical. good at pattern detection, prediction, classification, not good at common sense, emotions, understanding meaning like humans. ML is smart, not intelligent like humans. Common beginner myths that clear confusion. ML equal to coding only. No. ML equal to thinking, data, and code. ML replaces humans. ML assists humans. ML learns instantly. ML learns gradually. T9 assignment would be your task today. Write 3 supervised ML examples. Write 2 unsupervised ML examples. Comment below as day 9 done, ML concepts clear. Day 10 of AI 020, your first machine learning model. Yesterday you understood what machine learning is. Today you will build one. No theory overload, no fear. By the end of this video, you will train a real machine learning model, make predictions, understand how machine learning actually works. This is day 10, your first step into real AI. What we are building today? We are building a model that predicts house prices based on size. Why? Simple, powerful, used everywhere. This model is called linear regression. What is linear regression? Linear regression finds the best straight line that fits the data. Example, bigger house, higher price. The line helps us predict future values. Key intuition, find pattern, draw line, and predict new value. Tools we will use. You don't need advanced tools. We'll use Python, Pandas, NumPy, Scikit-learn, ML library. Reassurance, Scikit-learn does the heavy lifting. Install required libraries. They are pip install Scikit-learn, Pandas, and NumPy. They are Scikit-learn, Pandas, and NumPy. Run this once, that's it. Create a simple dataset. Let's create our dataset. Import pandas as PD. Data equal to query basis, KLU pairs, and then df equal to pd.data from data. Data is the KLU pair. Print df, it will print the dataset. Size is input, price is output. Step 3, split unit, split input and output. ML models need x as input, y as output. So the x equal to df under square bracket size and y is equal to df square bracket price. X equal to df square bracket size and y equal to df square bracket price. So size is input and price is output. Input must be in double brackets. Train the model. From sklearn in linear model import linear regression. Model equal to linear regression. Model dot fit in brackets x and y. This is where learning happens. The model looks at data. The model looks at data, finds pattern, stores relationship. This single line trains an ML model. Make predictions. Now comes the magic. Prediction is equal to model dot predict inside round square bracket 1100. Print prediction. The model predicts price for a house for a new house size. You just made your first AI prediction. Understand the result. The model is not guessing randomly. Relationship between size and price. Trend in the data. It, if size increases, price increases. ML truth. Predictions depend on data quality. Common beginner mistakes. If your code fails, check this. Forgetting double brackets for x. Not importing linear regression. Passing string instead of number. Read error messages calmly. What you just learned. You now know what a model is, how training works, how predictions are made, how ML uses data. You are officially doing machine learning. Data and assignment. Change the dataset values. Predict price for size 2000. Comment below as date and done. First ML model built. Day 11. Classification in machine learning. Yesterday your AI predicted numbers. Today it will make decisions. If this email spam or not? Is this transaction fraud or safe? Welcome to classification, one of the most important skills in machine learning. This is day 11 and by the end you will build a real spam detection model. Regression versus classification. Let's clear the confusion first. Output is a number. Example, house price, temperature. Output is a category. Example, spam, not spam, pass, fail. If the output is label, it's classification. What we are building today, we'll build a spam email classifier. The model will learn from examples and decide spam or not spam. This is exactly how Gmail works at scale. What is logistics regression? Despite the name, logistics regression is used for classification. Why outputs probability converts probability into classes. Example 0.8 spam, 0.2 not spam. Simple idea, probability is equal to danger. Step 1, import libraries. Import pandas, scikit-learn, logistics regression, scikit-learn, matrix. These are standard tools used by ML engineers. Create a simple dataset. We'll start simple. Data equal to message length, number of different numbers is found inside that numbers. Df equal to pd dot data frame data. Data equal to message length and is found. Print the df. 0 equal to not spam. 1 equal to spam. It is presenting is spam variable. Explain clearly. Explain clearly. We convert real world info into numbers. Split data into input and output. X equal to df double square bracket inside message length. Y equal to df square bracket is spam. X equal to input feature. Y equal to target label. Step 4, train and test split. We don't test on training data ever. X train, X test, X train, X, Y test. Train test split XY. Test size equal to 0.3, random size 42, random state 42. Key concept, train to learn, test to evaluate. Step 5, train the classification model. Model equal to logistic regression. Model dot fit inside bracket X train, Y train. This is where the model learns what spam looks like. Step 6, make predictions. Predictions is equal to model.predict x test. Print inside bracket predictions. The model is now making decisions just like a spam filter. Check accuracy. Accuracy equal to accuracy score inside bracket y test predictions. Print accuracy equal to accuracy. Accuracy colon equal to colon and accuracy. Accuracy tells us how often the model is correct. Real world connection. In real life, spam detection uses message text, keywords, sender info, user behavior. Today you learn the core idea, the same logic scales up. Simple models power complex systems. Common beginner mistakes. Avoid these errors. Forgetting train test clipped. Training on very tiny data and expecting magic. Confusing labels 01. Start simple then improve. Your task today. Change the dataset values. Try predicting spam for message length 150. Comment below day 11 done. Spam classifier built. Now day 12. Model evaluation explained. Accuracy, precision, real recall, confusion matrix. Your AI model says it's 90% accurate. Sounds amazing, right? But what if it misses frauded transactions? What if it marks important emails as spam? Today data you will learn how to measure AI performance properly. Because a model that looks good can still be dangerous. Why model evaluation matters? Machine learning is not about building models, it's about building real, reliable models. Bad evaluation leads to false confidence, wrong business decisions, real world damage. Good evaluation leads to trust, improvement, safer AI systems. Key line evaluation tells us if the model deserves trust. The confusion matrix core concept. Everything starts with the confusion matrix. Four possible outcomes. Spam is true, positive, false. Not spam, false, positive, true. These four values describe every classification model. Plain English meanings are TP equal to correctly predicted spam, TN correctly predicted not spam, FP not spam marked spam, FN spam missed very dangerous. Metric on accuracy. Accuracy answers one question: how often is the model correct? Formula don't memorize. Accuracy equal to TP plus TN by total. Example 90 correct prediction out of 100. Accuracy is 90%. Accuracy is good but not always enough. Why accuracy can lie? Imagine this dataset: 95 normal emails, 5 spam emails. Model predicts everything is not spam. Accuracy 95% but spam detection failed. Key lesson: high accuracy not equal to good model. Metric 2 precision. Precision answers. When the model says spam, how often it is right? Simple meaning: high precision equal to fewer false alarms. Used when spam filtering, legal cases, medical diagnosis. Precision focuses on false positives. Metric 3 recall. Recall answers out of all real spam. How many did we catch? Simple meaning. High recall, fewer misses. Used when cancer detection, fraud detection, security systems. Recall focuses on false negatives. Precision versus recall. You can't maximize both perfectly. Increase precision, real recall may drop. Increase recall, precision may drop. Rule of thumb, spam detection. Precision matters, disease detection, recall matters. Key line, metrics depend on the problem, not ego. Mini code example. From sklearn.metrics import classification report. Print classification report in bracket by test predictions. This single line gives precision, recall accuracy. Used by professionals daily. Common beginner mistakes. Avoid these mistakes. Trusting accuracy alone. Ignoring false positive negatives. Using wrong metric for the problem. Golden rule, business problem decides the metric. Date-well assignment. Explain in your own words. Accuracy, precision, recall. Answer this, which metrics matters more in the cancer detection and why. Comment below. Date well done. Model evaluation clear. Day 13. Feature engineering. The secret sauce of machine learning. Two people use the same algorithm. One model gets 65% accuracy, the other gets 90%. Same data, same algorithm. The difference, feature engineering. Today, day 13, you will learn the real skill ML engineers use to win competitions and jobs. What is feature engineering? A feature is an input the model learns from. Feature engineering means creating, modifying, selecting better inputs from raw data. Simple example, raw data, date of birth, engineered feature, age. Models understand numbers better than raw information. Key line, better features, better algorithms. Why feature engineering matters? ML models don't understand meaning, they understand patterns in numbers. Bad features, confused model, low accuracy. Good features, clear patterns, high accuracy. Truth, most ML improvements comes from data, not models. Type 1 feature scaling. Different features often have different ranges. Example, age 0 to 100, salary 10,000 to 1 lakh, 10 lakh. Build big numbers, dominate small numbers. This thoughts ML. Solution scaling. Min max scaling 0 to 1 range. Standardization, mean equal to 0, standard equal to 1. Key ideas. Scaling puts features on equal footing. Type 2 encoding categorical data. Models don't understand text. Example, city equal to Mumbai, Pune, Delhi. Level encoding Mumbai 0, Pune 1, Delhi 2. Can introduce false order. One hot encoding Mumbai 100, Pune 010, Delhi 001. No order, one hot encode. Type 3 feature creation. Sometimes the best feature doesn't exist. It must be created. Examples, height plus weight equal to BMI. Clicks per time engagement rate. Total marks percentage. AI mindset, ask what information really matters. Handling missing values. Missing data confuses models. Options: remove rows, fill with mean median, fill with most common value. Rule: never ignore missing values. Type 5 feature selection. More features, better model. Irrelevant features add noise, reduce accuracy. Good ML uses only useful features. Key idea: simple models with good features win. Mini real world example. Let's imagine a student performance model. Raw data: name, roll number, study hours, attendance. Useful features: study hours, attendance. Useless features: name, roll number. Models don't care about identity, only patterns. Common beginner mistakes. Avoid these traps. Feeding raw text directly to models. Ignoring scale differences. Keeping useless columns. Golden rule: if you wouldn't use it to decide, you don't give it to the model. If you wouldn't use it to decide, don't give it to the model. Day 13 assignment. Given this data, height, weight, create new feature BMI. Identify two useful features, two useless features for student performance model. Comment below. Day 13 done. Feature engineering unlocked. Day 14 end-to-end machine learning mini project from data to prediction. You have learned Python, Pandas, machine learning, evaluation, and feature engineering, but here's the real question: can you build a complete machine learning project on your own? Today, day 14, we'll build an end-to-end machine learning project step by step, from raw data model prediction. This is the most. This is the moment where learners say, "Yes, I can actually do ML." What we are building today? We'll build a simple but powerful project. Student performance prediction. Input: study hours, output: pass or fail. Why this project? Easy to understand. Uses real ML logics, same structure as industry projects. The end-to-end ML pipeline. Every real ML project follows this pipeline. Understand the problem, collect and load data, clean and prepare data, select features, train model, evaluate model, make predictions. Key line: algorithms change, pipeline doesn't. Step 1: create load data. Using this, you can load the data, fail, pass. This is supervised classification data. Import pandas PD data is equal to study hours result QL pair. df pd dot data from data print df. This is supervised classification data. Explore the data. Print df dot head, print df dot describe. Always ask how many rows, what are the columns, any missing values. Habit builder: never train before exploring data. Data preparation: our data is already clean, but in real life, this step is huge. X equal to df study hours, y df result, x input, y output. Step 4: train test split. From skill and model selection, import train test split. X train, X test, Y train, Y test. Train test split in the inside bracket X, Y. Test size 0.25, random state 0. Test size 0.25, random state 0. We train on past data and test on unseen data. Key idea: testing simulates the real world. Step 5: train the model. From learning linear model, import logistic regression. Model equal to logistic regression. Model dot fit X train Y train. This is where the machine learns the pattern. More study hours is higher chance of passing. Evaluate the model. Evaluate, Evaluation tells us, is the model reliable? Can we trust predictions? Reinforce accuracy alone is not enough. Make real predictions. Hours equal to double square bracket 5. Prediction equal to model dot predict hours. If prediction 0 equal to 1, then student will pass, else fail. Congratulations, you just built a complete ML project. What you just learned. Let's pause and reflect. You learned how to structure an ML project, how data flows through a pipeline, how models are trained and evaluated, how predictions are made. You now think like an ML engineer. Common beginner mistakes. Avoid these mistakes. Skipping data exploration, training without evaluation, assuming model is perfect. ML is iterative, not instant. Day 14 assignment. Modify the data set, add more study hours, change past fail labels, test prediction for study hours 2 and 7. Comment below day 14 done, end-to-end ML project completed. Now day 15. What is deep learning? Neural networks explained simply. Machine learning predicts house prices, but how does AI recognize faces? How does it understand speech? How does ChatGPT write like a human? The answer is deep learning. Today, day 15 will understand what deep learning really is, how neural networks work, why deep learning powers modern AI. No formulas, no confusion, just clarity. Why machine learning is not enough. Traditional ML works well with small data, simple patterns, but it struggles with images, audio, language, complex patterns. Example, writing rules for face recognition, writing rules for speech. Key insight, complex problems need layered learning, deep learning. Layered learning, deep learning. What is deep learning? Deep learning is a subset of machine learning that uses artificial neural networks inspired by the human brain. It's called deep because it has many layers. Deep learning equal to learning complex patterns using layered networks. Biological brain versus artificial neuron. Let's simplify a neuron. Human neuron is equal to receive signals, processes them, sends output. Artificial neuron inputs numbers, weights, importance, output value. Key idea, neurons are decision makers. Structure of a neural network. A neural network has three main parts: input layer, hidden layer, output layer. Input layer receives data, pixels, numbers, words. Hidden layer learns patterns, combine features. Output layer final prediction, cat, dog, pass, fail. Key line, more layers equal to deeper understanding. How deep learning learns. Intuition. Learning happens in three simple steps. Make a prediction, measure error, adjust weights. This repeats thousands of times. Analogy, like learning cricket, you swing, miss, adjust, improve. While deep learning is great at images, deep learning sees images in layers. First layer edges, middle layer shapes, final layer objects. Result face recognition, digital medical imaging, self-driving cars. Why deep learning is great at text and voice. Language is complex and sequential. Deep learning understands context, meaning, order. That's why voice assistants work, translation works, chatbots feel human. Machine learning versus deep learning needs manual. Machine learning deep learning needs manual features, learns features automatically, works with small data, needs large data, simple models, complex layered model. Deep learning equal to automatic feature learning. Common beginner myths. Let's clear confusion. Deep learning is equal to impossible. Deep learning equal to learnable step by step. Need PhD math. Need intuition plus practice. Only for big companies. No, used by individuals and startups. Used by individuals and startups. Day 15 assignment. Write in your own words what is deep learning. Why do we need it? List three real life applications of deep learning. Comment below. Day 15 done. Deep learning basics clear. Next 15 days in part 2. Thank you.